June 6th, 1944. All 6:30 hours. The Bay of the Seine, Normandy. You're standing in a steel box and the world is trying to kill you. The air is a thick, nauseating soup of salt spray, diesel fumes, and the vomit of 36 terrified men. Every time the flat bow of this boat slams into a 10-foot Atlantic swell, the cold seawater pours over the gunwales, soaking your wool uniform until it weighs 50 pounds. To your left and right, the horizon is choked with the greatest armada ever assembled, but your world has shrunk to the 4 armoured walls of this tiny craft. Through the roar of the surf you hear it, the rhythmic, mechanical thrum, thrum, thrum of German MG-42s. They aren't aiming at the ships anymore, they are aiming at you. For centuries military doctrine said this moment was impossible. You cannot land an army on a fortified beach. To get close enough to shore, a ship's hull would strike the sand hundreds of yards out, leaving soldiers to wade through chest-deep water, while machine guns turned the surf into a slaughterhouse. If the tide went out, the ships would be stranded, helpless sitting ducks for coastal artillery. The German High Command was certain of this. They looked at the shallow, treacherous beaches of Normandy and saw a natural fortress. They believed that without a deep-water port like Cherbourg or Le Havre, the Allies could never land enough tanks, enough bullets, or enough men to sustain an invasion. But they didn't know about a foul-mouthed, hard-drinking boatbuilder from the swamps of Louisiana. As the ramp of your boat begins to rattle, ready to drop into the chaos of Omaha Beach, you aren't riding in a masterpiece of naval engineering from the Pentagon. You're riding in a modified Eureka boat, originally designed to haul illegal moonshine and cypress logs through the shallow bayous of the American South. How did a man who spent his days fighting the US government and drinking his weight in scotch end up building the vessel that would save Western civilization? To understand the miracle of D-Day, you have to leave the blood-soaked sands of France and go back to a place where the water is just as brown, but the enemies are much more personal. August 15th, 1937. The Louisiana Bayou. 104 degrees. The humidity in the swamp is heavy enough to drown a man standing up. Out here, where the water is more mud than liquid, and the cypress knees wait like jagged teeth to rip the hull out of any boat, Andrew Jackson Higgins is in his element. He's a man built like a bulldog, with a voice like a gravel mixer, and a temper that keeps the local police on speed dial. He stands on the edge of a prototype boat, a cigarette dangling from his lip, watching his crew test the Eureka. The Eureka wasn't built for war. It was built for loggers, oil drillers, and the occasional bootlegger who needed to navigate the treacherous, shallow white water of the coastal marshes. Most boats of the era had a pointed bow and a deep keel. If they hit a sandbar, they stuck. If they hit a log, the propeller shattered. But Higgins had a different idea. He designed a spoon-shaped bow that allowed the boat to ride over obstacles rather than through them. More importantly, he tucked the propeller into a recessed tunnel in the hull, protecting it from debris. It was a boat that could run at full speed, slam onto a beach, and then, through a feat of sheer mechanical stubbornness, back itself off and go again. Back in Washington, D.C., the United States Navy's Bureau of Ships looked at Higgins' designs and laughed. They were big Navy men. They believed in massive steel hulls and deep-draft vessels. To them, Higgins was nothing more than a loudmouthed contractor from the sticks who didn't understand naval architecture. For years, the Navy tried to design their own landing craft. They failed. Their boats were too heavy, their engines stalled in the surf, and their ramps were cumbersome. Every time they tested a Navy design against a Higgins boat, the New Orleans wild man humiliated them. But Higgins didn't just want to win a contract. He wanted to win the war he saw coming on the horizon. He began buying up massive stockpiles of mahogany and steel before the government even placed an order. He was gambling his entire company, his reputation, and his fortune on a single conviction, that the next war would be won on the sand. As 1941 approached, the Navy finally buckled. They realized their own designs were death traps. They handed Higgins a contract, but with the impossible catch. They didn't just need a boat that could hit a beach. They needed a boat that could drop a massive steel ramp at the front so an entire platoon could storm out at once. The problem? Removing the bow of a boat usually makes it about as seaworthy as a bathtub. Higgins had 3 days to solve a problem that had stumped the world's best engineers for decades. October 1941, Higgins Industries, New Orleans, 02:06 hours. The lights in the City Park plant haven't been turned off in weeks. The air is thick with the scent of sawdust and the sharp ozone tang of welding torches. Andrew Higgins is pacing the floor, a scotch in one hand and a pencil in the other, staring at a set of blueprints that shouldn't work. The Navy had thrown him a curveball that would have broken any other man. They wanted the Eureka boat, but they wanted the bow chopped off. They had seen pictures of a Japanese landing craft at the Battle of Shanghai that featured a folding ramp, and they demanded the same. But adding a heavy steel ramp to a wooden boat created a structural nightmare. It made the vessel nose-heavy and prone to folding in half when it hit a wave. Higgins didn't call a committee. He didn't ask for a 6-month feasibility study. He gathered his best engineers and told them they weren't leaving the building until the ramp worked. In a frantic 72-hour design marathon, Higgins and his team redesigned the entire internal framework of the boat. They realized that by using a specific V-shape at the bottom of the ramp and reinforcing the sides with mahogany plywood, they could maintain the hull's integrity while providing a wide, flat path for 36 men to sprint onto a beach in seconds. When the prototype was finished, they didn't take it to a Navy testing ground. They hauled it to the choppy waters of Lake Pontchartrain. Higgins watched as the boat slammed into the shoreline at full throttle. The ramp dropped with a mechanical clank, and a group of local volunteers charged out. It didn't sink, it didn't stall, it worked perfectly. But solving the engineering was only half the battle. Now, Higgins had to solve the impossible math of global war. The Allied High Command didn't just need a few dozen boats. They needed thousands. They needed an industrial output that the world had never seen from a single city. Higgins responded by turning New Orleans into the largest boatyard on the planet. He bought up the municipal airport, the local lumber yards, and even the city's vacant lots. He ignored the segregated norms of the 1940s South, hiring black workers, women, and the elderly for equal pay, telling anyone who complained, "I don't care what colour you are or what's between your legs. As long as you can weld a seam that doesn't leak, you're on the team." By 1943, Higgins Industries was producing nearly 700 boats a month. But as the first massive shipments of LCVPs began to arrive in England, a terrifying realization started to circulate among the Allied planners. They had the boats and they had the men, but they were about to send them into a death zone that no boat, no matter how well built, was designed to survive. May 1944, the coast of Normandy, France. Darfur, hours. While Higgins was turning New Orleans into a whirlwind of industrial fury, across the English Channel, Field Marshal Erwin Rommel was busy building a nightmare. He knew the Allies were coming, and he knew they were coming by sea. His solution was the Atlantic Wall, a sprawling 2,000-mile chain of concrete bunkers, minefields, and jagged steel obstacles designed to turn the French coastline into a graveyard. Rommel's most devious invention wasn't the heavy artillery. It was what lay beneath the waves. He oversaw the installation of millions of hedgehogs, 3-lobed steel beams welded together, and Belgian gates, massive iron frames rigged with telemines. These weren't meant to sink ships in deep water. They were designed to tear the bottom out of any landing craft that dared to approach at high tide. This created a tactical paradox for the Allied planners. If they landed at high tide, the obstacles would be hidden underwater, shredding the Higgins boats before they even reached the sand. If they landed at low tide, the boats would be safe from the mines, but the soldiers would have to sprint across 300 yards of open, muddy beach, the death zone, directly into the teeth of pre-range machine gun fire. The success of Operation Overlord hinged on a razor-thin margin of error. The Allies needed a boat that was nimble enough to weave between those steel traps, shallow enough to get the men close to the dry sand even at low tide, and durable enough to survive the brutal Atlantic surf. Every other landing craft in the Allied arsenal had a major flaw. The larger LCT's landing craft tank were slow, massive targets. The smaller, British-designed boats lacked the engine power to retract from the beach once they landed. Only the LCVP, Higgins' Plywood Palace, offered the perfect balance of speed, manoeuvrability, and a shallow 3-foot draft at the bow. But even with the right boat, the human cost was going to be staggering. On the eve of the invasion, Allied meteorologists were tracking a massive storm front moving into the channel. The waves were swelling to heights that would capsize a normal small craft. General, Eisenhower sat in a cold stone room in England, holding the fate of 2 million men in his hands. He looked at the reports of Rommel's defences and the churning grey water of the channel. He knew that if the Higgins boats failed, if they stalled in the surf or couldn't handle the weight of the equipment, the invasion would collapse. There was no plan B. There was only the wild man's mahogany boats and the bravery of the boys inside them. As the first ripples of dawn broke over the horizon on June 6th, the order was given. Thousands of LCVP engines roared to life at once, a sound like 1,000 chainsaws cutting through the morning mist. The whiskey maker from New Orleans was about to face his final exam, June 6, 1944, Omaha Beach. 06:42 hours. The world is a cacophony of screaming metal. You're no longer in a boat, you are in a target. The Higgins boat's plywood sides, barely an inch thick, offer no protection against the 7.5 mm shells whistling down from the bluffs, or the Hitler's buzzsaw machine guns raking the shoreline. As the LCVP's flat bow grinds into the shingle of Normandy, the coxswain, often a teenager who had never seen the ocean a year prior, shouts the two words that define the end of one nightmare and the beginning of another. Ramp down. With a heavy mechanical thud, the steel front drops. For the men in the front row, the view of France lasts less than a second before they are cut down. But here is where Higgins' genius changes the course of history. In any other boat, a stalled engine or a fouled propeller at this moment would mean a total blockade of the beach. The boat would become a fixed obstacle, preventing any other troops from landing. But the Higgins boat was built to be a predator of the surf. Even as bullets stitch across the engine housing, the grey marine diesel engine screams with 225 horsepower of pure American defiance. The coxswain doesn't just sit there, he throws the boat into reverse. Using the V shape of the hull and the protected propeller tunnel, the LCVP pulls itself off the sand, spinning around in its own length, and disappears back into the mist to fetch another 36 men. By the end of D-Day, over 1,500 Higgins boats had participated in the initial waves. They were the mechanical lungs of the invasion, constantly exhaling men and equipment onto the shore and inhaling to bring more. They didn't just land the infantry, they brought the medics, the radio operators, and the engineers who would eventually blow the Atlantic Wall apart from the inside. As the sun set on June 6th, the impossible had happened. The Allies held a foothold in Europe. Back in New Orleans, Andrew Higgins didn't stop to celebrate. He knew the Pacific was next. His boats would go on to storm Iwo Jima, Okinawa, and Guadalcanal. By the time the war ended, Higgins Industries had produced over 20,000 LCVPs. To put that in perspective, Higgins built more than 90% of the US Navy's entire fleet during the war. He had taken the Eureka boat from the swamps and turned it into the primary vehicle of liberation. Years later, in 1964, the great historian Stephen Ambrose sat down with General Dwight D. Eisenhower. He asked the former Supreme Allied Commander which general or what piece of technology was most responsible for the victory in Europe. Eisenhower didn't hesitate. He didn't name the B-17 Flying Fortress or the Sherman tank. He named the man from New Orleans. "Andrew Higgins is the man who won the war for us," Eisenhower said. "If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different." The wild man passed away in 1952, but his legacy remains etched into every grain of sand on the beaches of Normandy. He was a man who saw a problem the experts said couldn't be solved, used the tools of the bayou to build a solution of mahogany and steel, and gave the Allied forces the one thing they needed most, a way to get home by going through the front door. Every time you see those iconic grainy photos of soldiers jumping into the surf, you are looking at the house that Higgins built. A whiskey-drinking, rule-breaking boat builder who proved that sometimes, to save the world, you don't need a committee, you just need a better boat.